Hey everyone, today we are looking at lesson 7.3, which is domain and range of quadratic functions. Now, domain and range is not new to us. We have learned it in the past, and so we're reintroducing it, but with a new kind of graph that we've been learning about, the quadratic function. So a few things that we need to be able to know is, can we explain the difference between domain and range? Do you know what the difference is? That's half the battle on the STAR test, is knowing the difference between domain and range. I can determine what the domain range is from a graph, from a table, an equation, and make sure I'm using the correct inequality symbols, less than, or equal to, etc. So that's our learning target for today. Let's go ahead and look at what is the difference between domain and range. I know you've seen this visual before. If you haven't, you're seeing it again now. Dr. XY. Domain are x's, you can see it in red. Domain are x's, range or y's. Remember, x, just like the x-axis, moves from left to right. So we're wondering how far left does our graph go and how far right does it go? So for instance, on this graph, this quadratic function, keep in mind that it has arrows. So that is important to this. A lot of people think, well, the furthest left it goes is -2 and the furthest right is 4. Not so. These arrows mean that it keeps going and keeps going. So our graph is going left and right forever. So our domain then is all real numbers. All real numbers, all negative x's, all positive x's, all x's. And that's wonderful. And that means it goes left and right forever. But what about up and down? That's where we're starting to look at the range. Okay, so the range you can see there in blue, and we're wondering what our range is here. So looking at it, the range, remember, is up and down. So we're wondering how high does the graph go and how low does it go? The lowest it goes, and I can, on the STAR test, you would have to use your finger to do this, but I can draw on it and see the lowest it goes is -1. But it doesn't have a highest because, as I said earlier, it does go up forever. It has no highest point. So all of our y values are all greater than or equal to, because there is a point at -1. Remember, that's the vertex. Not greater than or equal to -1. All of our y's are above, greater than, or equal to -1. Okay? There is no highest point. We only use the lowest point. That's an example of a graph that has arrows. But sometimes we might have a graph that has endpoints. So let's look at an example of that. Okay, so in this particular one, it has endpoints, so it's a little easier actually. I think most students struggle when it has arrows. This isn't so bad. Domain, I'm going to keep with the same colors, red for domain and blue for range. So domain is red, and we put an X in the middle, and we see how far. Remember, domain are x's, so we're wondering how far left and right does this graph go? The furthest left it goes is -1, and the furthest right it goes is 2. So -1, leaving a space there, x, and then leaving another space, and then 2. Now, what goes in these spaces? Hopefully you remember, okay? But if you don't, I'll write it down here at the bottom. An open circle means we're using less than, or, yeah, sometimes greater than. And a closed circle means we're using less than or equal to. You have that bar at the bottom. So the -1 has the closed dot, less than or equal to, and the +2 has an open dot. So it is just less than. Now we're going to do range. Okay, range, remember, is up and down. So we're looking at our y's this time. So put a y in the middle. And we're trying to see how high up it goes and how low it goes. It does have a highest point at 4. The vertex, right, is at 4. And the lowest our graph goes is 0 on the y-axis. Remember, you have to look at the y-axis, not the x-axis. Okay? So the lowest it goes first. It's always smallest all the way up to biggest. Now at 0, we have an open dot. So it is just less than. Okay, you can see it right here. But the highest we go is 4, and it's a solid dot. There is actually a point there. That's the vertex, right? So it gets a less than or equal to symbol. So our domain, all of our x's are between -1 and 2, and all of our y's are between 0 and 4. That is an example of a graph that has endpoints. Last but not least, we're going to look at an example of domain and range from a table. Let's see. Ooh, I like it. Oh, we have 2 more examples, sorry. Domain and range from a table. So looking at a table, we can tell a lot. First and foremost, let's label it X and Y, okay? Remember, domain is red, so our X's are here. That's our domain. Okay, I'm going to even write the word domain above it. And then our range is down here. X is always on top in a horizontal table, and Y is always on bottom. So that will be our range. So keeping in mind, this is a real world problem, so it does change things a bit, okay? The domain is starting at 0 and it's time. We are not going to have like a negative time or distance. So keep that in mind when we're writing our domain and range. Now in this particular problem, it asks what is the range. So we're talking about the y's. So let's have a look at our y's. Notice something that happens right here. These two match. And these two match. And then there's one that's here in the middle, and it's the highest the graph goes. This is like a vertex, guys. That's the vertex of the graph. Okay, so keep that in mind. It is the vertex of the graph. So when we know the vertex, we know either the highest point or the lowest point. In this case, you can see that the numbers start at 0, get bigger, get all the way up to 7.66, and then start getting smaller. So keeping that in mind, if I were to sketch a quick graph of this, okay, it starts at 0, 0, that's the origin, and it's going up all the way to 7.66, and then it's coming back down. Sorry about that. Going up to 7.66 and coming back down eventually to 0, right? Because it will land on the ground. So our range would be from 0, y goes in the middle, right? 0 feet all the way up to 7.66 meters, sorry, not feet. And they are included, so it's less than or equal to. Not 766, sorry, 7.66. That is our range of this ball. The lowest it's going to go is stay on the ground, 0 meters, but it does reach a height of 7.66. And remember, this point right here is the vertex. That is a maximum. It's the highest it goes. Now let's look at an equation. And how can we find out what the domain and range are with just given an equation? It's interesting. Here's our equation. The best thing you can do is graph it. Graph it in your Desmos calculator and see. First of all, this is a regular function. It doesn't have endpoints. It's going to go on forever. So the domain should be very easy. Okay, our domain is all real numbers. Again, there are no endpoints. This is not a real world problem. And let's go ahead and have a look. Maybe pause your video and open your Desmos calculator, type in the equation, and then we'll look at the range of it. Okay, guys, so here is our parabola. You can see that it does continue to go down forever, guys. It really does. And it's going left and right forever at the same time, which is why our domain was all real numbers. It goes left forever, it goes right forever. It covers all the x's. But it does not cover all the y's because it does have a maximum here. There's the vertex. The highest it goes is 4, but it goes down forever. Okay, let's draw a quick sketch of this. We have roots at 1 and -3. So I'm going to draw a quick sketch of what this looks like. Okay, right here at 1 and -3 are the roots. And then all the way up here at -1, 4 was the vertex. It looked something like this. Okay, and we could see it in the Desmos calculator. So our range, remember, how high does it go? The highest it goes is 4. So all of our y's are all below that 4, so less than. If you're not sure if your symbol is less than or greater than, remember, make an L with your hand and then squish it, and it becomes less than, okay? So less than or equal to, because there is a point there at the vertex, 4. The X's, remember guys, the arrows tell us that it goes left forever, it goes right forever. So it's all real numbers. All right, pause the video, and I want you to try all 3 of the star questions that are on the right, and then unpause the video to check your answers. Hey there guys, the first star question, remember you're given an equation, put it in Desmos, and you can see what the graph looks like. The domain of an equation is always all real numbers, so keep that in mind. But what is our range here? The lowest our graph goes on the y's is -8. So our range is, our graph is above -8. So our y's all have to be -8 or higher. So our range is that our y values are greater than or equal to -8. Now in this particular one, they don't use y, they use n of x. So keep that in mind, okay? So I'm looking for n of x is greater than or equal to -8, which would be this one, okay? And all it took was graphing it to see that -8. The domain is always all real numbers, unless for some reason like this one, you have endpoints, okay? Other than that example, you will always have a domain of all real numbers. Now, the second one, I will admit, was pretty tricky, okay? Because it had fractions, but guess what? You can find out what these fractions are as decimals. See, I wrote them out right here. And so it went from 1.75 to 4 to 4.75, back down to 4, back down to 1.75. So you can see it slowly got bigger and then started getting smaller again. So 4.75 was the highest it went, otherwise known as 19/4. And I drew a sketch of it as well, and I could see that the highest it went was 19/4. And so my graph, my range, which is what it's asking for, the y's, are less than or equal to 19/4 because they're below 19/4. Okay, now let's look at the very last one, and that would be this one. First of all, knowing whether you're doing domain or range, this is domain, so it's x's, and then it wrote it in words. So what I did was on the side, I wrote it using our inequality symbols over here, okay, so that you could see exactly what it is. Okay, so keep that in mind. This is the domain. Now I can see from graphs A and D that they have the -4 on the y-axis, and we're looking for domain, which is x. So definitely A and D are out. But then when I look at C, the arrow goes left, which means all these numbers are below -4, less than -4. Whereas here, it starts at -4 and it goes right in answer choice B. Okay, and that's all numbers bigger than -4. We wanted less than according to the problem, so we choose C. Okay, these are some example star problems, and there's so many ways you can eliminate wrong answer choices. And the STAR test is going to be here before we know it, guys. We've only got about 2 months until the STAR test, but we'll get there and we'll make sure that you're prepared for it, okay? Have a great day, guys, and if you have any questions, please make sure to see me.